Okay. Try using this.
So when you open it, this would be two.
Okay, number two, for lack of a better term, we're going to call it the identity property. I just put ID standing for identity. Okay. And the identity property says any value, let's say A, to the first power is going to be equal to what? Itself. A. Those two are pretty easy, pretty basic. Had those many times. Okay. Number three, we had what was called the product property. Product meaning multiplication, right? So if I take two bases and multiply them together, let's just say a to the third times a to the fourth. When I multiply the bases, what do I do to the exponents? I'm sorry? I add them. So this equals a to the 3 plus 4, which we get out of our calculators and we realize that 3 plus 4 is 7. Hopefully you don't need a calculator. That was supposed to be a joke. So we multiply, we add the exponents. Number 4, when we dealt with exponents, we had the quotient rule. I know that's what I'm saying now. The quotient rule or the quotient property. And quotient means what?
Answer and division.
The answer and division problem. So we're going to have a division in here. Now, if we think about it, multiplying, we add the exponents. So if I'm dividing, I'm going to subtract the exponents. They're inverses. Okay? Multiply is adding, its inverse. Dividing would be subtracting. So let's say I had something like, and we can write this in several different ways.
Hey, Mr. Phillips,
Hey, what's up?
is Ella in class?
Yep.
Could you send her to the front office, please?
With her stuff, or is she coming back?
With her stuff.
Okay, there you go.
Thank you.
See ya. This will be on YouTube. I'll post this later. So quotient. Why are we yelling at me?
You have YouTube?
I do. The link should be on Schoology.
Oh, that's where you post these videos? I've been wondering where they go.
Okay.
Are we good?
Yeah.
Okay.
Will this
I'm-
part be on
Check this
YouTube?
one.
Yeah.
Yeah.
Don't you have the link already?
Yeah.
Why?
Okay, so here's what I'm going to do. I don't have. Any other interruptions? Fantastic. So here's what I'm going to erase this and scoot it to the top so you in the back can see it because is this getting too low? It's getting too low for me to lean over. So I'm going to erase it, put it on that one up. So number 4, the quotient property. So if I have a division, something like x to the 10th divided by x to the 3rd, or maybe it looks like x to the 10th divided by x to the 3rd, one of those. What am I going to do with those exponents? Subtract. So x to the 10 minus 3. So that would give me x to the 7. So the quotient property. 2 more, number 5. We have the power rule or the power property. So that means if I have an exponent to an exponent, I'm taking a power to a power. So something like x to the 5th to the 4th power. X to the 5th to the 4th power. So what do I do with those exponents? Well, so that's going to be x to the 5 times 4, which gives me x to the... The two that people get mixed up are the power rule and the product rule. When do I multiply the exponents and when do I add them? Notice in the product rule, how many bases do you have? Go back to the product rule. 2 bases. Power rule, how many bases do you have? 1. Difference between them. Okay? Recognize that difference and know that kind of helps us remember which one do I do. Number 6, the last one. This really isn't a rule, it's more of a reminder. This is more of a definition than it is anything. If I give you x to the negative 3, what does that negative exponent tell me to do? Negative exponent. Anyone?
Divide.
Yes. So what would I write?
X
Give me
divided
the
by
final.
X divided by X.
Say it again?
X divided by X divided by X.
Nope.
Isn't it 1 over x cubed?
Correct. So the negative really just tells me to move it. It's all about location. If it's in the numerator, I simply move it to the denominator and make it positive. So x to the negative third equals 1 over x to the third. What if it was already in the, let me erase up here. What if it was already in the denominator? What if I gave you something like 1 over x to the 5th?
X negative to the negative 5th.
Okay, that's exactly right. So we move it to the numerator. I hear some talking to the negative 5th. Quiet, please. You simply move it to the numerator and change the sign. The negative sign is all about location. Notice that this negative sign has nothing to do with the value being positive or negative. Has nothing to do with that. All that exponent does, all that negative exponent does is tell us where it goes. I'll back up. All it does is tell me where to go, numerator to denominator. Okay, review of exponent rules. Okay, review of exponent rules. Are we good with those? Now, while the soccer team is leaving, the rest of us are going to go through all the logarithm rules. The same one. The first one's going to be called zero. Second one's identity, product, quotient, power. Exact same type of idea, but we're going to walk through the logarithms form. Okay? So we're going from exponential form to log form. So, page, what page are we on? 2. So at the top, you're going to write the very first rule, which is what?
0.
Zero rule of logarithms. Zero rule for logarithms. So I'm going to write, let's see, we're on page 2. So I'm going to write the zero rule. And if you want to put in logs, you can. If you just want to realize it is logarithms, just do that. So it would look like this. I would have log to any base. I'll go back to that idea of any base A. The log of any base A. Did I use A in my notes? Of 1 is going to be equal to what? Log base of any base. A could be 5, it could be 1,000,000. If this is a 1, what's the answer? No.
10.
It's called the zero rule for a reason.
0?
Zero. Because think about it, if I swoop it, it's A to the 0 power equals 1. If I swoop it.
Yeah.
Okay.
That makes a lot more sense.
Make that connection. Yep. All right, so I just have a couple examples written in here because these are pretty basic. Something like log of 42 of 1 equals 0. What if I did the logarithm of maybe 4,300,000
We got it right then?
of 1? What does it equal?
0.
Whatever helps you remember that it's always 0. If this argument is 1, the answer is 0. industry. You got it?
Yeah.
Okay, page 2, page 3. Page 3.
Teachers, please excuse this interruption. We need soccer to report to the lobby. Please check your email and make sure those students that are on that email are the only students being released. Again, soccer, we need you to report to the front lobby. Thank you.
Okay, so page 3. That was short, sweet, to the point. Thought about putting 2 on 1, but I like having them on different pages. So what's the second rule? We had the 0 rule, now we have the, what'd you say? Identity. Once again, this was going to be for logs. Okay, it's going to be related to that. So if I have log to some base A of A, what's that going to be? One.
Yeah.
Because if you swoop it,
Oh,
A to the first
Yeah.
equals A.
Yeah.
So as long as these two are the same, it doesn't matter how big it is. Okay, it doesn't matter what they are. As long as the argument and the base are the same, the answer will be 1. Like for instance, log to the base square root of 7 of the square root of 7 equals 1. As long as they match, the answer is always 1. Enjoy these two because they get more complicated. Okay? In fact, with time, we may not finish this. Okay, we good? Can I erase it?
Yeah.
Outstanding. Page 4. You might want to write a little smaller on this one. You know how big you've already written. Page 4. What's the rule? We had 0, we had identity. Product rule. Outstanding. So product rule for logs. Okay. So that means somewhere here we'll be multiplying something, correct?
Yeah.
Okay. So let's go with log, and then let's make parentheses, and let's put in something in there that's being multiplied. Okay? Let's say x times y. Now, when we did exponents, when I multiplied, what did I do to the exponents? I added the exponents. So here, if I have logarithms and I'm multiplying the argument, I can simply split them up, make it into, and I apologize, I probably shouldn't have capitalized that. It doesn't really matter, I just don't want to confuse you. Okay. It's going to be the log of x plus the log of y. You can split them up, and then you simply add the two logarithms separately. Now, when we start solving problems, this will be a great tool to split things up. For instance, let's give you this one. Log to the base 3 of 3x. So go ahead and split up that 3 and x into two separate logarithms. Okay? Give me a second to jot that down. So the first one would be what?
Log 3.
Of 3 plus log 3 of x. We had 3 and x, 3 and x. Now, does anyone see something else we could do? Sorry? You can't really solve it. There's another way to simplify it.
Log to the 9.
What is log to the base 3 of 3? You just learned it 3 minutes ago. It's 1. So you have simply 1 plus log to the base 3 of x. And we can simplify. I'm going to erase, we're going to write one more example on here. And basically it's the example going backwards. Let's say I give you something like log of 4 plus the log of x plus the log of 6. Put that back together. So what do I do to the 4, the x, and the 6? I don't add them. Or what do we add? What do we do when we're adding logarithms? We multiply them. So I end up with the log of what? 24 x. When you're going back together, when you see plus, that means you take those arguments and you multiply them together. You got that? Did you have 24x? All right, we'll practice more of those on pages 7 and 8. Okay? I want to get on with the rest of the rules. Okay? What's the next one? What's page 5 going to be? Quotient. Okay? Page 5. Quotient. Once again, this one's for logs. So we have something like log, and then we'll use that x and y again. X divided by y. Just like the exponential rule, when I have division, what did I do to the exponents? Subtracted them. Okay? So now that I have x divided by y as my argument, when I split it up, what do you suppose I'm going to do?
Log divided by x, log divided by y.
Not going to divide.
Oh, subtract.
I'm going to subtract.
Yeah.
Okay? And in fact, remember the negative rule, right? The negative, you move it to the denominator. So if it's in the denominator, that's the one that's minus. Okay? So I have log of x. It's in the numerator, so there's a plus sign in front of it. Minus log of y. And since y is the denominator, that becomes the negative. Just like x to the negative 3, you moved it to the denominator. The same thing, y is in the denominator, that's going to be the minus. It's going to be the negative exponent. So let's try this one. Log of, let's say, 3x over y equals. Oh shoot, I had one before that. That's right. Yes? Suppose.
I just didn't know if anybody was.
So, how many terms do I have inside this argument?
2.
How many? I have 3, right? 3x and y. So how many times will I write the word log? 3 times. So if you haven't, go back and fix it. So you should have log. And what are the 3 terms there? 3x and y, right?
Yeah.
So 3x, y. Okay. What signs go in front of them?
Should it be
Yes.
positive or negative?
Which ones are positive and which ones are negative?
Log 3 positive, log x negative, log y.
Did you tell me log y is positive or negative?
Negative.
Negative. You told me log x is positive or negative.
Positive.
Why?
Because it's at the top.
Hmm?
Yes.
I could have sworn you said negative log x. Was I just hearing wrong? Okay. That's the correct answer right there. The denominator is the one with log of y, it's the one that's negative. All right, let's try one more. You guys do this one? Log of 7 over 8y. And then we'll do the last one. Emma, what's my answer?
Sorry, hold on, I spaced out, I'm sorry.
Sydney, what's my answer?
Log 7, I think we need subtraction. Minus,
Minus what?
log 8. Minus log y.
Perfect. Everything on the denominator becomes minus, numerator stays positive. All right, very good. Page 6, what's page 6? Power. Power rule, this is my favorite. This is actually the one when it comes to solving you'll use a lot. So let's say I have something like log, we haven't been doing base very often, so I'm just gonna leave it at 10, leave it blank. Log of, let's say, a to the b power. A is my argument, but it goes to a power of b. So the power rule of log says that that exponent, remember when we had power rule of exponents? What did I do to the two exponents? I had x to the 5th to the 4th power. I multiplied them, right? Okay. Well, logarithm powers are the same way. A log is an exponent. So I can simply bring that exponent b out front and multiply it by log of a. So if I have something like, you're gonna have this when we start solving next week. If I have the logarithm of, let's say, 3 to the x power, what that power rule tells me is, you know that x, it's unknown and it's in the exponent. I can bring it out of the exponent and bring it down front. So I have I have x times the log of 3. And you can simply bring it out front. Or vice versa. Let's say I have 2 times the log of 4. That's going to be equal to what?
Log 4 to the second power.
Say it again.
Log 4 to the second power.
Which is log of,
6 to 16.
yep, which is the same as log of 16. Correct. So that power rule gives me the freedom to have it down front or as an exponent, whichever way I need it. Soccer team back?
Sorry, this way.
Not you, it's just us hoping the soccer team. All right. So we did all 5, what's one did we not do?
Reminder.
The exponent, the negative exponent? We kind of did that though.
Coach Ostergaard to the front office. Coach Ostergaard to the front office.
We kind of did that with the negative exponent. If it's negative, it goes to the bottom, or it goes to, if it's on the bottom, it goes to negative. So kind of that. So, here's where your homework is. Your homework is going to be one of two things. Page 7, it's going to say expand. Expand the log. So what that's going to mean is, it's going to give you something condensed log of, start off a little bit easier first, 3x squared over y to the 4th. And it's going to say expand that logarithm. So take a minute, apply what you've learned, apply the product rule, because you have 3 times x squared. Apply the quotient rule, because you have divided by y to the 4th. And apply the power rule, because you have 2 exponents. Apply all 3 of them, and then expand that as far as you can. Give it a try, go. Do it step by step, start with one rule at a time.
Should probably go back to. Section, yeah.
Yeah, well, it must be thought of English. So I'm gonna do log 3 plus log. Yeah.
Oh, one more thing about that EOC, I forgot. Not only do you have to put phones away, you have to put every single thing that connects to the internet, which means smartwatches, those have to be put away, everything, have nothing with you. Yes, we had some teachers block.
What if, okay, this is probably a really stupid question, and it's mainly just like curiosity, but like, what if somebody has like, well, I mean, this doesn't pertain to our school at all, I don't think, but like, if somebody at a different school had like an ankle monitor or something.
I mean.
So there are exceptions because we do have some students who use their phone, their watch for medical reasons, those type of things.
Mm-hmm.
So
Or
there
like
is,
someone with diabetes, if they have it.
so, and they have a medical, if it can connect to the internet,
Uh-huh.
there are some exceptions to that, but it has to be held by the test examiner. And it has to be, everything has to be turned off. Students can't have anything during the test.
What if they die?
It's called standardized testing, and there are
What if they
certain rules.
bullshit go low down?
So if we listen to music during
Nope.
it, or
Hell.
if you're listening to an audio recording.
Yeah,
Why would they let you listen to music?
you can listen to like a math podcast and it's.
You can't have anything.
So what?
Even
No,
I
no,
can't,
you
even
can
I
go
can't
like-
play music.
You know how like MP3 player. If you go like access the movie, you can have it like red. to
Okay,
you.
are we done?
You can like have the answers red. to
We
you.
done?
That's genius though. If you like express it, AirPods.
You need more time?
Yeah, a little bit.
Okay,
My
thank you.
iPod.
Hey, quiet please for, let those finish. I just saw you playing, and I thought, can't have this. And your computers will open up a browser, when you click on it, it'll open a browser that will not allow you to do anything else.
Like
Yeah.
WEA testing. NWEA
So you can't Google it.
Well, math.
You good?
pod.
All right, here we go. How many terms do I have?
English.
Hey, shh. How many, not terms, that's all I'm looking for. How many, arguments do I have? Not 5.
3.
I see where you got 5 though. There's gonna be 3. 3x squared and y to the 4th.
Oh,
Okay?
okay.
So I'm gonna go log of 3 plus log of x. And then when I do y to the 4th, it's gonna be negative log of y to the 4th. Okay, we got our plus on the top, plus and plus. We got our on the bottom, minus. And now I heard some of you say it. What do they do with those exponents? Bring them out front. So we have log of 3 plus 2 log of x minus 4 log y. And that should be, is that your final answer? Did I miss something?
So I shouldn't bring in the exponents first?
You can't. If you can go straight to here, that's fine. I just did it to show the steps.
So if I brought the exponents first, it'd be 8.
Oh, no. See, okay. Hey, this is a very good point. The 2 goes only to the x, because that's what it's closest to. The 4 goes only to the y, because that's what it's closest to. This is not the same as log of 3x over y squared. Those are 2 entirely different things. Because this 2 would go to every single one inside. Y squared. Okay. So those are different. You have to treat them as different. You have to look at what it's going to. I'm glad you brought that up. That's a very good point.
If there's a number, like 2 log x, if there's a number in front of the log, do you always know it's an exponent? Or it was an exponent?
Yes. Like if we just give you 5 log of y, yeah, that's log of y to the 5. This is an exponent. Okay, one more example and then we're gonna let you work. Are you ready? So page 8, last page. Last page. So page 7 was expand. What do you think page 8 is going to be?
Condense.
Condense. How'd you know that? It's written right there. Right? You're paying attention to the word. Condense. So now we're going to try to write it with as one logarithm. This is going to be a tool that we're going to use when we're solving equations. Everything is sort of spread out. We're going to try to get down to one log and then we can solve. Okay? It's going to be very important for next week. So let me take the example out of my notes. Should be on your last page, page 8. All right, here we go. Try this one. Log of x plus 2 log of 3 minus 5 log of y equals. Remember your rules. If it's negative, if it's minus sign, where does it go? If it's being added, where does it go? Think about those product, quotient, power rules. Okay, so as I look through this, I see a plus, and a minus. There's just an understood positive right there. So I know I'm going to have something on top and something on bottom. So I know I'm going to have a division. X, top or bottom? Top, because it's a plus. I can take that 2 and move it. So what's going to go on top there? Yeah, just if it's simple like that, just square it. It should be 9. Okay. And then on bottom, what's going to go there? Very good. Y to the 5. So my final answer is log of 9x divided by y to the 5th. And there's my answer. Okay, so I want you to get used to doing this. Don't do like 1 or 2 and say, oh, I've got it. Practice. Because there's some tricky things that go in there. On page 653, you have the top 4 say, I believe, expand. The bottom 4 say, condense. I think you could probably finish them before class is out. As long as you don't play around and stuff. You're done. I'm glad to help you if you need help.